So let's begin. In the next 60, 70, 80 minutes, we'll see how it goes. We are going to talk about testing, and we are going to see why testing, even though people tell you how to do it, is not that straightforward, but even worse, we may want not to test our applications. We may decide explicitly to stop testing the apps before releasing them to production just because it's not cost effective, as we are going to see throughout this presentation. We'll also focus on ways of testing apps, how to do that depending on different domains. And we are also going to see some couple of things that we should consider before or testing our applications during we design and develop the software that we would like to test afterwards. So let's jump straight to it. My name is Furmanek. I'm a software engineer for nearly 15 years now, author of these two interesting books, one about .NET, one about maths. So feel free to take a look at those. Drop me a line, email, Twitter, take a look at my blog at blog.adamfurmanek.pl. And that's it. If you happen to have questions, as it was already mentioned, drop them on a chat. I'll try to follow the chat here on the side screen. So let's go. So we are going to go through 4 important areas during this talk. So first, we are going to think if we need tests at all and why we need tests. Then we are going to actually answer the very important thing about how to design our applications. We can't test our applications if we don't implement them correctly. So we are going to see what's important when implementing the software so that we can test it confidentially later on, and so it's effective and very comfortable for us. Then we'll focus on some testing. I will actually share a couple of tips that I guess most of you know, and then we'll wrap up with like a list of various domains and want to focus on when we are going through testing our apps. So the very first thing to begin, do we need tests? Like if you are a seasoned software engineers, then probably your answer is obviously we need tests, right? Because this is what they teach us. This is why we have unit tests. This is why we have frameworks and libraries like JUnit or other stuff. So sure, we need tests. That's obvious. But then we do not test our standard libraries. No matter what language we use, .NET, Java, Python, JavaScript, yada, yada, we do not test our standard libraries. We do not test runtimes that we use, whether it's JVM, whether it's operating system, whether it's whatever else. The question is why? We say that we need tests, but we don't test runtimes. We generally assume they are kind of tested by their authors, right? But if you are seasoned developers that you know there are so many bugs around, and if you go and read changelogs of your platforms, then it's sometimes surprising how many times things are just broken for years. For instance, .NET was for many years was delivering their .NET runtime with an implementation of a priority queue that wasn't a priority queue at all. It was just named priority queue, but had a bug in it. Friends of mine found bugs in like JVM runtime when it came to concurrent dictionaries. I found bug in C++ runtime delivered by Microsoft. So bugs are everywhere, and yet we do not test that stuff. Why? We do not have 100% code coverage, right? So whenever we test our stuff, we do not try to achieve 100% code coverage, branch coverage, whatever other coverage you can think of. The question is again, why? We claim that we need tests, but we don't do that stuff. And obviously we know, hey, we don't run for 100% code coverage because there are pieces of code that they are not worth testing, right? It's not worth testing getters, setters, or other trivial integration code just because we assume it works, right? But still, we have to be aware of that we are claiming that we claim that we test our apps, but we miss those places. We drop some kind of tests, for instance, UI tests. For instance, we drop hardware tests. We don't use production components, but we use mocks instead. Again, why? Why don't we do that? And we probably, most of us been through that we tried testing UI applications, or web applications, we took Selenium, we took other libraries, and then we realized a couple weeks later that, hey, those tests are completely unmaintainable in the longer run. right? We can implement those tests, but maintaining them is basically hell. It's crazy hard to keep them in good shape. Another thing is like we mock external components. We test our stuff with different things than we use in production. In production, we have some Oracle database. In testing, we use H2 in-memory one, right? In production, we have some 𝐀𝐝𝐚𝐦 from AWS. In tests, we use mocks. Again, why? And we could go on and on and on. And yet another interesting stuff is, have you ever tested your software for like faulty memory or broken network packets or 𝐀𝐝𝐚𝐦 𝐅𝐻? We probably never did that. Again, why? And you may give reasonable answers why not doing that, right? We don't test runtimes because, hey, they have been tested by their authors. And even if there is a bug, then we probably submit a ticket for them, right? We don't test getters and setters because, come on, they are so simple, there is no need in testing them, right? We don't protect ourselves from like 𝐀𝐝𝐚𝐦 𝐅𝐻 because 𝐀𝐝𝐚𝐦 𝐅𝐻, seriously? And if we continue this conversation, then we can actually learn that according to statistics, even up to 80% of products' functionality is used rarely or never, meaning that we spend so much time implementing stuff which is then not used by our clients, by our customers. Those statistics are provided by the Standish Group, and they are based on surveys run every year. So they are not super, let's say, reliable, right? Don't consider them being like scientific facts, but still, those numbers repeat themselves every year. However, so we have enough reasons to not test our apps, and we claim it's still good. But let's see a couple of examples of what can go wrong. And on the right-hand side of the screen, we have a couple of examples when things really broke because they were not tested properly. Knight Capital Group was a company that was doing high-frequency trading, and they decided to repurpose one bit flag to do easier deployment, and they lost something like $500 million in nearly an hour. Why? Because of broken deployment. Mariner 1 was a spacecraft that when the people in NASA were implementing that, they missed one bar above, like inside a mathematical formula. That bar was very significant, and it caused the different results obtained from like detectors, which caused the spacecraft to go crazy, and they had to destroy it. Imagine that you implement a critical software for years, and then you need to destroy it because of a single typo in like your JavaScript code. I mentioned 𝐀𝐝𝐚𝐦 𝐅𝐻, and you may have laughed at that, right? But Belgium election in 2003, I think, the official result for one candidate was higher by 4,096 votes because of a 𝐀𝐝𝐚𝐦 𝐅𝐻. And this is an official explanation. You can go to Wikipedia and see that 𝐀𝐝𝐚𝐦 𝐅𝐻 is probably one of the most probable reasons behind that. 𝐸𝐻25 is yet another example where people actually died or were at least heavily overdosed of with radiation because of concurrency issue in the software. So yes, on one hand, we say we don't need to test getters and setters because, come on, they are super trivial. On the other hand, if we implement a software, and it does not need to be a medical software like in case of 𝐸𝐻25, but for instance, a regular financial software, we can lose big amount of money just because doing the deployment or incorrectly or a bug in our application. So at the very end of the day, it's all about the costs. Whenever we create a software, we need to understand that we don't build applications just for the sake of building these applications. Applications have a very specific and well-defined purpose, and we need to implement software so to meet the purpose, right? And testing is just one part of that purpose. We don't do testing for the sake of testing, but we need to test the stuff to minimize the cost of the error that gets deployed. And this is something that is actually hard to accept if we are craftsmen and if we really want to deliver the highest quality software. But reality is, no matter whether you are a small company, big Fortune 500 enterprise, one of the big corp FANG enterprises, the answer is always the same. If it's cheaper to deploy faulty software to production and the risk of big issues afterwards is so small, then we really want to avoid tests. And we want to deploy potentially faulty software to production just because it's cheaper. And I can see there is a question. First question, is there any techniques to verify that upcoming deployments is going to succeed? Is it testable at all? We are going to actually talk a little bit about it a little bit later. So I'll answer that question later on. But in short, generally, there are some techniques, but they are not perfect. We'll get to that and see when they do not work good enough for our cases. Coming back to the slide. So it's all about the costs and the risk. We want to risk taking the toll if it's cheaper to fix the toll, fix the penalty, and pay the penalty afterwards, instead of paying much more now to do the tests. And as hard as it may sound, this is how reality goes. We can build the best software, but it's better, like more cost effective, to deliver the software which is potentially broken. And now it's up to us, up to the management and the technical people to assess this risk. What's the acceptable risk that we can take, and what the issues we can let go, slip through the cracks and be delivered to production, and which risk we really want to avoid to not deploy them to prod. And before moving on, let us actually consider one more thing. We could actually think, how much should we test? And we could take a tale of two programmers. Let's say that we have two perfect guys, two perfect folks. Both of them never make mistakes. Both of them implement perfect code according to the specification and whatnot. First guy tests after writing every single line of code. Second guy never run tests. Who is better? Who of these two is better? And like, you may think, okay, that's a, let's say, handcrafted example, not showing anything, because, well, we are not perfect programmers. We'll always make mistakes. But the point we want to consider here is, it's not about being perfect. It's about making trivial changes as big as possible. We don't test getters and setters because, hey, they are trivial, right? Especially if we have compilers that verify whether we actually return the value and whatnot, right? But sometimes even getter can be broken if we have like polymorphic methods and very old legacy code that when we touch one line of code, it all collapses, right? But in other cases, we may actually write even like 100 lines of code without writing tests, without testing that stuff. And it's still okay because it's a greenfield code. We know what we're doing, and the probability of us making the mistake is really low. So the whole point is about finding a balance. It's not about testing everything that may go wrong. It's not about dropping all the tests that we can. It's about finding, okay, which things I can test cheaply and which things are too expensive to be tested, and I need to drop that. Before actually going to see some tests, we need to understand that we need to make the software testable. And I'm not going to talk about the stuff that you need to, I don't know, make your methods protected for tests or virtual so you can override them or avoid statics, nothing like this. I want to focus on a completely different thing. In order to build the software, and to test the software, we need to have a good process of how we build the software, how we test it, how often we do that. And this process is not something about code quality. It's about how we deploy and deliver the software in general. There are three important aspects for us as developers that we really need to take into consideration when designing the applications so that we can test them efficiently. The very first aspect of developer experience is we need to be able to run tests, or generally everything, locally. Why? Because if we can't run tests locally, take your unit tests from your software. If they are running for like a minute, then obviously you are not going to run them every couple lines of code you implement, right? Because then you need to wait for a minute to run those tests, right? The same goes for other types of tests. You won't run load tests, integration tests, if they are just slow. If bringing up your database takes like 10 minutes, then obviously you won't run those tests. It's not about the quality of the code. It's about running the tests at all and testing the code at all. So it's important to have a proper environment, local environment, so that you can run your stuff locally. You could be actually surprised in how many companies you can't even run your applications locally. You need to deploy them to EC2 instances, to, I don't know, other cloud environments, and you can't just run things locally. If you can't do that, then obviously you won't be testing your software locally, and this will just testing the software will take way more time. The same goes for debugging stuff. The same goes for having tools configured, having IDEs configured, and whatnot. So generally, the first thing is we would like to have the software that we can run locally without having the connection to the internet, like when being on a plane. And in order to do that, we can use things like Docker containers, NICs, virtual machines, emulators where it's possible, remote debuggers, so we can connect to remote environments and ultimately have a full IDE support, something like have a good tooling support. And there is another question on a chat, which is, I had getters broken in Java with Lombok third-party library and Spring Framework because the name of fields were starting with single lowercase letter, then uppercase letter like string 𝐀𝐝𝐚𝐦. And this is actually a very good remark. Sometimes the code is generated by external libraries. Lombok actually generates piece of code in Java during compilation time. So it may be that this code, even though should be seemingly straightforward, doesn't work. The more magic actually we have in our applications, I mean aspect-oriented programming, polymorphism, dependency injection running in runtime, etc., those things are harder and harder to test. So this is a very good thingy. Moving on, that was the first aspect. So be able to run stuff locally. The other thing we need to keep in mind is we should be able to deploy the software or design the software so that we can automatically test feature branches. What I mean here is when I commit the code and I push it to repository to my feature branch, the code that may be broken, may not be perfect, may not be necessarily formatted even properly, I should be able to have all the tests triggered automatically with everything around. I mean, with real-life databases, real-life queues, real-life network connectivity, with load tests, integration tests, other stuff. This must be an environment that is exactly the same as the production one. No mocks, created from scratch, and replicating what I have in production. If I don't have that, then what happens is, okay, I implement my stuff on feature branch, then I would like to deploy it to some probably shared environment, so I'm blocking other teammates, or maybe I even need to merge my branch to the main branch. What happens if I merge and then I realize there was a bug? Well, I lose effectively days. So another thingy is we need to be able to test our stuff without blocking others and without others blocking us. And this stuff, ideally, we have a build system capable of testing feature branches that create completely new environment, probably using infrastructure as code, Docker, virtual machines, whatever else, with proper configuration, with all the designs, and that feature branch must be tested with everything we have. Load tests, integration tests, yada, yada. So this way, when you are done with implementing stuff, you push your changes and you know whether it works or not, whether it's safe to merge it to your main branch. And it's important that we are not talking only about like the application code. We are also talking about infrastructure as code. We are talking about the declarative syntax for Azure resources. We are talking about other stuff that generally is much harder to be tested. How many times you actually implement a change to your infrastructure with infrastructure as code, you apply it to existing environment and it works. But when you try creating a new environment from scratch, you run into, like, say, cyclic dependencies, and it doesn't work at all. That's why feature branch should be tested entirely from scratch, so you know what's going on, and at the same time, you can see whether it can be deployed properly or not. And finally, last aspect of this proper experience is everything needs to be automated. No manual steps should be needed at all. And I'm talking here mostly about configuration stuff. How many times you need to configure new DNS zone? How many times you need to go and copy certificates or create, I don't know, passwords in AWS KeyMaster, right? Those things really need to be automated. Otherwise, we can't scale and we basically waste time. And in order to do that, everything that you do needs to have a proper CI/CD, and all the deployments should be automated. Rollbacks should be automated thanks to alarms and monitoring. You should have like feature toggles for which can like help you rolling things back much faster in matter of like seconds, not necessarily hours. Generally, all the tests should be executed before and after the deployment. It is also important to execute tests after the deployment to verify whether our deployment was correct. Like, okay, we may know that our CI/CD works well, but generally you may hit a really stupid issues when you deploy stuff to production, and those issues may go unnoticed. So generally, make sure what you do and have these things automated. Apart from tests, when we are talking about making sure that our applications work well, is what you need to do is you need to have other tools, compilers, metrics, observability. There are so many things that you can wire up into your process to make sure that your application works well. You don't need to write unit tests to verify getters and setters. You can change your programming language to something like Haskell or Idris, where you can actually make sure that if the code is broken, it does not compile at all. And this is thanks to some more sophisticated like data structures or programming constructs, so we won't be going deep into those. But generally, by using a compiler, you can avoid many tests, and compiler should be the first thing you use to verify your code. There is a question on the chat. After deployment, tests are used directly against production. This is the question about what I said here. You should test your stuff after the deployment. Yes, those tests need to go against your production environment. Obviously, you cannot now modify the production data, or you need to have, I don't know, separate subset of data that you can use to run your tests in production. And those tests, this will probably not be the whole data set you have, right? Or the whole unit, or the whole test set you have. But carefully picked and carefully crafted critical paths need to be tested after you deploy to production. Otherwise, customers will find those bugs. And more often than not, things really break when you go to production, especially when we deal with different countries, different data distribution, and whatnot. Moving on. Now, let's see a couple of ideas, okay, how to keep tests maintainable. And what I want to stress in this part is tests are another piece of production code. I'm not going to tell you that you need to, keep it in the same perfect quality as you try to keep your production code, and that you should refactor tests every other day, nothing like that. But still, when implementing tests, make sure that you do apply typical best practices, because it's very easy to really break tests or implement them in a way that they are not maintainable. So we'll quickly run through a couple of good practices what to do. I guess most of you already know that, but I want to emphasize that, hey, just try applying those principles whenever you can. So the very first thing before even seeing the code is, why do we use mocks? We use mocks like Mockito, but also mocks like in-memory databases that are not production pieces. Why do we use them? Imagine a situation that you can run all your tests in basically no time with production components, production databases, production queues, service buses. All tests run in parallel, don't block each other, database is created just like it should be. All of them runs in like 1 millisecond, basically no time. Would you ever mock such a database or such a queue or whatever other production component? If the answer is yes, then I strongly suggest to reconsider, because the point of mocking is not to get rid of like production components, but the point of mocking is to make things faster and testable at all. But if you can test them with your production code, then don't use mocks at all, especially if you are doing TDD. There are actually two schools of TDD. One of them is Boston and the other one is London. And I think London school tells you to mock everything, to isolate as much as possible. And this is purely wrong. You shouldn't be testing mocks. You shouldn't be isolating your code. Wherever you can, you should use production components, production code, and not mock at all. And also keep in mind that whatever a mock is not only a thing that we do with, I don't know, Mockito or any other mocking libraries. A mock is anything that is used instead of a production component. So if you use H2 in-memory databases, if you use Azure emulators that tell you that they have 99 point something compatibility with production components, then you are still mocking. Maybe it's okay, because some mocks are smart, some mocks are good enough for our cases, and even if they let some issues to slip through the cracks, then it's not a big deal. But sometimes you should always ask this question, do I need this mock at all? And can I go without mocking the solution? And generally, yeah, this is basically what I said. If you do not run the production code, then you are still running a mock, no matter how clever the mock is. It can be nearly 100% compatible with production, still it's not a production. If you are running against Oracle database but with different licensing model than in your production, then you are still mocking your database. Probably it's not a big deal. Just like to come back to this first part, whenever we can, we should evaluate the costs and make sure what we do. But we can't just claim that we are doing testing with production components when we change even at the tiniest bit, because this is not a production component anymore. There is a question on the chat. Having embedded Kafka broker, part of Spring Framework, which is very fast and 100% compatible, can it still be reasonable to mock Kafka interactions? The answer is yes and no. Generally, what I'm saying here is you need to evaluate what you get out of using this mock. If your tests are too slow with the actual like Kafka broker, and you can make them much faster with mocks, and actually the thing that the tests are slow is a problem, then yes, mocking Kafka is good. However, if it's not a problem, performance is not a problem, maintenance is not a problem, I would not mock this Kafka then. Because it's not about, like I'm saying, isolating stuff. It's about testing the stuff that runs the way it runs in production. And if there are no problems with performance, with concurrency, with broken state, with fragile tests, do not mock. Moving on. How to write maintainable mocks. So we are going to go through that because, well, sooner or later we'll need mocks anyway. So generally, we are going through a couple of things. Do not repeat yourself, name your objects properly, don't generate data manually, don't repeat too much. So let's see a couple of examples. So instead of having like a Mockito when or any arrange thingy in your tests, generally create some helper methods that will pre-initialize the state for you and can be modified just in like one place, right? So instead of, we all been there, there is some test in here that we would like to copy because we need to write another test for status 2, right? So effectively we have code duplication, but those two variables are effectively the same. The only difference is in like one tiny variable or one tiny property of those. So generally extract that state to some helper method that will initialize everything and use builders for that. Then you take builder and you can override whatever properties you need and just create the final object, right? One tiny change and it can make your test way more readable. Another thingy, name your test objects. Do not call your objects like status2 or whatever else, but instead name your repositories for tests like showing the business definition and the business meaning, right? So it's not about that status is set to status2. It's about that, hey, this thingy is ready to launch. Sometimes, just like we have magic numbers in our production code, The same, avoid magic numbers, magic names in your tests. Name them properly, have proper repositories for your test objects, and keep your tests better this way. Do not generate data manually. How many times we were actually creating new object where field 1 is 1, 2, 3, field 2 is set to some string ABC and whatnot. Don't do that. There are libraries that can deal with that. For instance, there is auto fixture library that can create an object for you, which you can basically use just like the regular object with pre-filled real life and like, you know, very decent data. Don't hard code your data, because first, after like a couple of weeks, you have no idea whether this value 123 has some actually special meaning. And second, don't spend time on doing that. Computers are pretty good at generating stuff, especially with ChatGPT and OpenAI now, right? So generally avoid manual steps where possible. And ultimately, one of the like practices that we see so many times in our tests, that we have the test names like operation 1, situation 1, and outcome. Like test, I don't know, buying a ticket, customer not registered, failure, okay? And so on. And we repeat those names over and over and over again. Don't do that. You can group your tests into some basically meaningful names. In some libraries, it's super easy because you have scenarios with string names and whatnot. In some other languages, for instance, in Java, you can use nested classes, right? So group all your tests into like operation 1 class, and then have just situation and outcome, and that's it. This way, you can also make things even clearer, because now if you need to pre-initialize the state, then you can pre-initialize it in here, in this class only, and this won't affect the initialization here. So this helps you maintain more readable tests just by applying those, you know, tiny principles. And now, being all of that said, let's actually move on to a couple of domains. So we already considered whether should we test or not. And the answer is always, it depends. You need to evaluate your costs and your benefits and how hard it is to test the stuff. And now we are going to actually see a couple of domains and think what can go wrong and how to efficiently test these domains. Before going into any specific domain, I'd like to stress one important thing. Whenever you mock something, mocks need to be based on contracts. It's not that we mock behavior, it's that we mock contract. Contract is typically specified as preconditions, invariants, and postconditions, and we can also break something which is called history principle. If you would like to read more about that, generally Liskov substitution principle is about that stuff. However, it's important that we can verify the contract as scholars. I mean, the author of the interface, the author of the contract cannot verify the contract for you. They are physically unable to write tests so that to verify that you implemented the contract properly. And where I'm getting at with that is that contracts do not need to be written down in the code. Unfortunately, most of our languages are just not capable of defining all the contracts we may have. For instance, we can specify that given function accepts only lists of integers, and this is also a part of the contract. But we, in our typical languages, Java, .NET, C#, JavaScript, Python, we can't enforce that this list of integers must have at least 2 elements, right? Some languages let us specify those conditions. For instance, Idris can help us doing that, or in Scala we can do those stuff, but generally we can't enforce that. And in that case, the remaining part of the contract is written down typically in the documentation or in the tests, but we need to be aware of the contract and include only things that are included in the contract. So whenever you mock something, always mock the contract, not the actual behavior. And in the meantime, there was a question on the chat. Is it a good practice to keep the data of test objects in files, then read them as resources and parse to test objects instead of constructing in place? So generally, instead of having, let's say, Java code that creates new object with properties, we just load JSON object from a file, and this way we create those objects. Is it a good practice? Depends. Generally, if you can put those files next to the code base, so they are not hard to find, and they are also can be verified with XSD schema or JSON schema or whatever, then it's definitely a very good solution. Actually, in some cases, that's the only solution we can do, right? Sometimes those test objects are really, really big, and in that case, we can't keep them in the code. We need to encode them in separate files. So definitely, this is a good practice in some scenarios. Cool. So being that said about mocks, I'm not going to consider this example because we do not have enough time. So let's carry on. Let's say that we use infrastructure as code in our software. Now, infrastructure as code has many benefits. We can scale environments easily. So instead of, doing things manually in AWS console, Azure console, or wherever else, we just have a Terraform file, Azure Resource Manager, CloudFormation YAML file, or whatever, and we just deploy it to the account, right? And it works. Another thingy that infrastructure as code brings us is that, hey, with infrastructure as code, we can test feature branches easily. But because we just take the feature branch, we take the declarative description of the infrastructure, we create it in place in some new AWS account or whatever, and we run our tests, and we can tear things down, and we can verify whether all works. However, infrastructure as code poses other issues tied to the IAC directly. For instance, what about permissions, especially any kind of allow listing, right? If you need to allow list IP addresses that are, I don't know, allowed to call an API, or domain names, or whatever else that requires manual intervention, then infrastructure as code actually becomes, well, it still works, but it's kind of against the point. It's not automated anymore, just because you need to go and you need to manually allow for some IP addresses or whatever. So just taking infrastructure as code is not enough. We also need to automate stuff around. So if you are changing your application to use IAC, then be aware that there are some things that may be very hard to automate. For instance, domain name servers, etc., etc. What about dynamic IP addresses? What about self-signed certificates? You can always generate self-signed certificate, which is cool, but then this certificate may cause some issues on dependent services because it's self-signed and not trusted at all. If you want to get trusted certificate, again, it's a little bit of work that you need to do. Another thingy with infrastructure as code is, hey, you need to create a copy on your environment on the side. This may be super expensive and super time consuming. Imagine that you want to test machine learning solutions. You need to basically get GPU enabled machines, and they are way more expensive than regular EC2 instances, right? Not to mention that getting those machines, deploying them, installing operating system, or even bringing up Docker containers, this will take minutes. At least minutes, and it may go even longer, right? What about licenses? Maybe we cannot just deploy, I don't know, yet another Oracle instance because we don't have Oracle instances, licenses for another Oracle database engine, right? Also, for the time, how long does it take you to deploy new VPC, new networking, new machine, new databases, pre-fill it with data and whatnot? Generally, those things can easily go into like hours. So it is super slow. What about things when they break, when you can't get enough hardware? Because, for instance, AWS doesn't have more GPU enabled instances for you. So whenever you go in infrastructure as code, just be aware that those things also, first, are not that straightforward to use, and second, they may be very expensive and also should be tested the same way. Many companies I worked with had this issue that they use infrastructure as code, They create environments and then they forget, and they are paying like hundreds of thousands of dollars just because they have EC2 instances running and doing nothing for months. Those things happen. Just be aware of those because, well, it's super easy to get costs when you go with IAC. Another thing, let's say that we want to test ETL, extract, transform, load domain applications. So ETL basically is an application that takes data from multiple sources, let's say file storage, SQL database, NoSQL database, loads all of that data, transforms to some common representation, and puts, for instance, in a data warehouse or any data lake, which can be then used by, I don't know, machine learning solutions or reporting or whatever else. Whenever we deal with ETL, there are actually two important things that we need to consider. First thing is there may be issues which we just won't spot when running stuff in production. They will go unnoticed and they will break the dataset ultimately. For instance, different representation of dates. If you have day, month, year, or the opposite, month and then day, it's super easy to actually, mix these two. And many libraries, many frameworks will not give you an error. They will just silently ignore this issue. Same goes for decimal separators. Same goes for character encoding, for missing values, especially that sometimes we encode missing value as basically null in the database, but in CSV files, we can't encode empty string and null value differently. So we would need to store, I don't know, NA, not available, not applicable, but then we end up with strings of value NA, right? This is super important when we test this stuff or when we consider this stuff, because our process, our ETL process, will ultimately work properly. It will succeed and all the jobs will be green, but we'll get wrong data set at the very end and wrong result. So this is something we need to keep in mind, that, hey, some things we can verify with unit tests, but generally many things we can't test in the isolation with unit, but we need to do end-to-end test with minimal amount of data. So what we should do in order to test ETL is basically have some golden data set, small data set that we know what it consists of, what's there inside, and then run ETL process on this whole data set. This could be, I don't know, 1,000 of records, right? Doesn't need to be super big, but still should show you all things you use. And especially if you, for instance, use Spark or MapReduce or any other scalable solutions, then you need to test networking and marshalling of your code. Especially with Spark, that's often the case that you implement some Scala code or PySpark code in Python, that when you run it in the cluster, it just cannot work in distributed fashion because, well, the code cannot be sent between workers. And this is something you won't figure out with unit tests. You won't figure it out with integration test that runs on a single machine. You need to basically spin up the Spark cluster with at least 2 machines and see how it goes. So generally, always test that stuff. Think through what tests you can write in advance, but also consider which things and how to represent all those edge cases in your golden set that you run end to end. And ultimately, one last thing to consider when actually designing ETL applications, always think whether you can delay your processing. Sometimes we run things like daily, sometimes we run them every hour. How much of a problem it is that you don't generate report by 6 p.m. in the evening, but for instance, it will be available 4 a.m. the following morning, right? How much of an issue that is? You need to think that through, because when things breaks, when you don't deploy them properly to production, then you need to know whether you need to catch up with the data set processing or not. So also keep that tested and know how you can scale out. Another thingy, machine learning. How can we test machine learning domains? So the problem, there are actually, again, a couple of issues with machine learning. First, testing ML is expensive because we need to basically do the training and do the inference on the actual data sets. We can't test those things with unit tests because, well, they won't even show us whether the model will learn anything and whether the result is what we expect. Actually, you need to always have some input data set that you train your model on and that you know how it should behave, what output of the inference you expect, what should be the ROC metrics, what should be anything statistical KPIs that can tell you whether the model was trained properly or not. And running that thingy with decent data set is again expensive. You will need to have GPU-enabled hardware. So generally, those are the things that you need to be aware of, that, hey, testing ML is actually super hard these days. And also important part is quality of your input data may break your machine learning training, even though you increase the quality. There was a case in one of my production systems when, after cleaning the data better in the ETL, like preparing the data part, I cleaned the data and improved generally the quality of the data set, which led to different distribution of values. And that different distribution then ultimately led to machine learning not converging. So the machine learning model couldn't learn anything just because it was observing completely different distribution than it was tuned and prepared by researchers before. So generally, even making things better can break your machine learning stuff. Now, how to test it generally? Always test with golden sets. So generally, make sure that you have tiny data set that you can run with your unit tests, just to make sure that, hey, things actually compile, they work, there are no sec faults, no stupid typos in Python code, etc., etc. And then have another test suite that would run the same machine learning code, but for some actual production data set. By production data set, I mean something which can be, I don't know, a subset of your production data, or maybe a data from just one single country that you need to support. Just run machine learning solution on that and observe all the metrics. With those two things, you can kind of reliably say that those things will work in production when it's done. And again, if something bad happens, it's always good to understand whether you actually need to retrain the model, or maybe you can accept some outage. For instance, if you are training a model for recognizing images, it's probably not a big deal if your pipeline gets blocked for a couple of days, because, well, you'll continue using the older model, right? Nothing breaks. But if you are working on a recommendation system, then this recommendation system needs to be aware of everything that happens right now. So even like 6 hours of delay can have tremendous impact on your business metrics. So generally, always be aware what happens if you can't retrain the machine learning model on time. When it comes to user interface tests, or generally any hardware tests with mobile phones, with printers, or with some IoT or embedded stuff, right? Generally, first thing with those tests is they are fragile. They work, but they are very hard to maintain. And the important stuff we want to do is we want these tests to be slow but stable. If we can make those tests faster but more fragile, don't do that. If you can't make them reliable, make them slower so they fail less often. Generally, follow some good practices like record tests, take screenshots when something breaks, so that you know what's going on. So generally, when testing that stuff, and I'm talking about desktop apps, web apps, etc., you need to have like two different types of tests. First test is focusing on correctness for the most critical paths and most typical scenarios you have. If you are implementing, let's say, a mobile application, just test the most commonly used mobile phones used by your customers. If you are doing web browsers, focus on the most common browser that your clients use, right? Make sure those tests are slow. Those tests fail only if there is really something wrong. And if they are red, go and fix them as soon as possible. and have another set of tests that checks different conditions, for instance, lack of memory, some less popular mobile phones or less popular browsers that test things, I don't know, with different resolutions, right? Let those tests run and generally accept the fact that they can be read to some extent. And now important stuff. It's not about generally making sure that they are green or letting them rot and be always red, but it's about tracking each particular test case, how often it's read. I mean, if you have 100 tests, it's acceptable if 90 of them are green and 10 of them are red, as long as with every execution, it's different 10 tests that fail. So if you can make sure that your tests generally, they fail spuriously because this is what's going to happen, but still it's not that the same test is failing over and over again, then it's kind of acceptable. So instead of having 100% green tests, just add some alarms whether a particular test case fails for too many executions, right? If it fails 10 times in a row, that's probably a problem. If it failed 3 times and then succeeded, maybe it's not a big deal, and this can wait until we have some more time to, work on these tests and see whether everything is in good shape. So this is what you need to do. And unfortunately, I'm not aware of any better solution. I mean, those tests will be fragile, will break. The matter is how to make sure that we notice when there is something wrong, not when something fails spuriously just for the time being. Now, when it comes to code hygiene, we can never prove. There is a question actually, so let's read it. What would you recommend for the case when the majority of the code is doing interaction with some complicated third-party hardware, like power-generated control unit? What can be approaches for testing the code, like mock the hardware part completely, or else sometimes it might be reasonable to implement an emulator, but this is a very expensive task. Yes, generally there is no solution to that. I mean, you need to run this test if using the actual hardware is impossible because it's too expensive, you don't have access, etc., etc. Then you need to have an emulator for that. I understand building an emulator is really hard. Maintaining the emulator is expensive and time consuming, but there is no other way. So now you basically need to actually answer different question. Do I need to run these tests every single time? Maybe I do because it's hardware and it can, for instance, harm people, right? So in that case, I need to run those tests and I just need to accept the cost and just pay it. But maybe I don't need to run those tests every time. So in that case, I can actually less them less frequently and accumulate changes over time. And maybe for the time being, it's good enough to mock the test. For instance, I take the documentation, I check the contracts, and I mock this hardware to run my tests locally, run them for the whole sprint, and then at the very end of the sprint, we take the test suite and run it against physical hardware. There is unfortunately, not a solution for that. I mean, imagine that you are testing a printer. Well, you need to print those pieces of paper. There is no other way. Everything else that you do is basically mocking, and mocking may let you slip through the cracks. If you can write an emulator, do it. But I understand it's super expensive often, and we just can't maintain this emulator over time. So in that case, unfortunately, we need to find the balance, how often we need to test, how much we want to pay for these tests to avoid the issues. And sometimes the answer is actually, well, we don't test, we just deploy to production. Obviously, again, first part of this talk, it's about the risk and the toll we want to take. Moving back to code hygiene. Generally, we can never prove the code will work. This is important because we can always prove that the code worked before. If we want to prove the future, well, it doesn't work here in this universe because we have stuff that may break anytime. I mentioned cosmic ray. You won't prove that you are protected from the cosmic ray because, well, physics won't let you do that. But still, we can use stuff that is going to help us. Compilers, linters, static code analysis, type systems, and other stuff. Generally, use those tools as much as possible. Just remember that those tools are supposed to help you. If you break your build before running unit tests just because your code is not formatted well, maybe that's not the right approach. Maybe formatting the code should happen at the very end of your build system or whatever else. And important it is to understand that you want to check features, not behavior. So generally, test the stuff that do the property testing instead of behavior testing, instead of checking actual lines of code. If you want to test your sorting procedure, the property you want to test afterwards is whether the numbers are sorted, not whether a proper pivot element was being selected in quicksort. So generally understand what you want to test, check contracts, and run as many tools as you can. If you have mutation tests, figure them out and use them the same way. Chaos engineering, the same way. Generally use your compiler to prove properties with 𝐀𝐝𝐚𝐦 and other stuff. Do it the way. But if you want to verify your code correctness, there are also tools for that. For instance, if you are working in distributed domain, you can use TLA+. TLA+ can help you prove that your distributed concurrent code is actually working well and you don't have any concurrency issues. TLA+ is, for instance, used by Azure, by AWS in DynamoDB. So generally, this is a solution that can help you as long as obviously you have the need and you can afford the cost. You can use declarative models like SAT, IOP, CSP, and other stuff that you use, and you use them to define what you want to achieve and not how you want to do that. And those tools will figure out whether you are doing the right job. Use high-level architectural patterns. Generally, good system is designed in a way that you have some input, you do some processing in between, and then you have some output. As simple as that, that's the pattern for building good software. If you can module your applications this way, then you understand it, and then you can see the code or the solution is of a good quality. So use patterns that let you get closer to this input, processing, output, and that's it. Use other frameworks that can take care of the hard stuff. Don't implement concurrency on your own. Don't implement transaction isolations on your own. Don't implement consistency protocols or anything like that, like Paxos or Raft. Take solutions that are there and make sure that you use them properly so they maintain their behavior. Another question is, that was actually, I think, about the last slide. The same problem with OTP, one-time password codes, how to automate the process of testing them. That is actually the question, what you want to achieve. If you need to use OTP during the process, probably fixing the randomness seed could be the solution, so you know what OTP code is. If you can't do that, then actually I don't know the answer. It's the first time I would be, I never used OTP in testing procedures, so I would need to think about that. But generally, I would probably consider something about, fixing the randomness, just like with everything else that is based on random stuff, for instance, even machine learning training. If we can fix the seed, then we know what to expect. So this is what we typically do in machine learning stuff. Maybe that would work in this scenario as well. Moving on, we need to wrap it up a little bit quicker, so let's carry on. Load tests and comparison tests. Generally, whenever you run your application, whenever it's web server or whatever else, you can replay the traffic that you get in production and replay it against your developer environment or testing environment or whatever else. The important part here is you can take the traffic from production, but you need to make sure that you do not break, I don't know, red data or confidentiality or personally identifiable information or GDPR or California Protection Act. Make sure what you do, anonymize your data, and then use this data properly to reproduce in test environment to make sure that your application still works. The problems you may have here is randomness. statefulness of your applications. So like you can't just take the request from production and run it against your testing database because, hey, you don't have production entities in testing database, right? Different data distribution. If you take traffic from the US, you probably can't replay it against the European data hosts, right? So make sure what you do, make sure that you have proper distribution, that you anonymize the data properly, sample the data properly. So it's not that you take only the most common REST API, but that you sample all the APIs properly. And also be aware that there may be some non-significant differences that you should be aware of and you should accept. For instance, differences in, I don't know, timestamp, or differences in some randomly generated values, etc., etc. One interesting thing, though, you can do here is you can change the way you log stuff to encode the state of what you log. So, for instance, you can take all the functions that you execute, and you can log the input parameters and the output state of each function. And then you can actually compare that when running in testing environment. So you can see and create all your unit tests based on the logs that you have from production. This is actually can be a very powerful technique. However, it requires, specific domain and dealing with statefulness and randomness and other stuff. And if you run load tests or comparison tests of whatever case, always think about caches. Always be able to stop those load tests at any time, just because they may cause issues on other teams, cause tickets, etc., etc. And also be aware that when you are replying the traffic against environment, you should be able to recognize that given requests are actually from tests, not from production. I mean, because when something breaks and you actually have red tests, or tickets or alarms or monitors on the dashboard, then you need to be aware and be able to answer whether the things that broke just because you were testing something and that was a test request, or whether that was a production one. Moving on, when we are talking about load tests, they do work and they can test many things. The problem with those load tests is they happen way too late. Way too late because they happen typically at the very end of the pipeline. So we already implemented our changes, merged them to the branch, deployed to some environment, and only then do we realize that, hey, this application is not working well and load tests find them. The problem with that is that we often verify only the correctness of our applications, especially when we are talking about databases, about ORMs, about interaction with data sources. When we run select statement on SQL database, we don't verify how it executed the query behind the scenes, whether it used indexes, whether it used a proper, transaction isolation level, whether it used proper query hints, right? We only take the outcome of the query and we take the correctness of the data set that we extracted from the database. And this is not enough. Load tests will protect us from that. I mean, they will figure out that, hey, now you have n+1 problem in your SQL query, or you stopped using index because now your queries are way too slower. But generally, this is way too late, and we need to be able to do that earlier. So generally, always keep your databases in sync between environments. Analyze execution plans where possible. See that, check whether your database used indexes, used query hints, or whatever else. And verify if those execution plans, they do scale well when you go to production. Whether you don't have n+1 queries, whether you don't use table scans, whether you have good time complexity, and whatnot. So generally, those are things that you can verify locally just by examining the interaction with your database or any other data source. But this is something you need to do extra. It's not something that you can do just by checking the output of the SQL query, whether it returned proper results. Another thingy is for configuration. Like if you change the configuration, if you remove indexes, if you change something like the size of your machines, if you change tables to views, change partitioning, sharding, and other stuff, generally it's always easy to let those issues go unnoticed, because again, You will have correct results when you test the stuff with unit tests, but those things are not executed completely differently. And the things are working differently in the database. So how to do that? Well, make sure that your configuration is declarative and you do not modify the configuration manually. Verify again execution plans. Check the configuration, whether it changes over time. Go to your database and verify whether indexes that you configured 6 months back are still used, and ultimately have anomaly detection in place. Have some system around that will verify that, for instance, this particular pattern when it comes to requests is actually going slower or over time or something like this. Check your logs, verify, look for different metrics depending on country, depending on customer cohort, depending on subscription plan and whatnot, to look for the actual differences that are there in production. Yet another technique you can use is documentation as code. So instead of having diagrams somewhere in Wiki, in Confluence, or wherever else, you can generate the documentation automatically. And there are tools that you can use to generate, for instance, markdown files that represent the data flow between REST APIs or network endpoints, right? You can generate those markdown files when running unit tests, and you can keep those these markdown files in your repository. So then when you change the behavior, you not only see the broken tests or red tests or whatever else, but you also see changes in the diagrams, and they show you way more. For instance, hey, now I coded this API and I wasn't expecting that. And when it comes to the documentation, synchronize your repository with Confluence and wikis and other stuff. Do not keep those two independent, because then they will go out of sync. Try keeping your documentation as code using plant UML, using Markdown, using other human readable formats that can be later automatically translated into wiki pages or whatever else. Same goes for design documents. Do not create design documents in Word online that is completely independent from your stuff, but keep those design documents in like ARC42 or C4 in your repository so that you can easily search for it and you can see when things change and keep them close. Now, another thing that we can do is, instead of even testing the application before going to production, we can use A/B tests and feature toggles. So what we can do is, whenever we build a new solution, we can deploy it to production without testing it at all. Some companies actually don't even have testing environments or pre-production environments at all. What they do instead, they do the blue-green deployment. So they deploy the stuff, and then they have some feature toggles or A/B tests that let you decide on a load balancer which fleet actually handles the stuff. So you can deploy a new application side by side with the old application and then route the traffic properly or load balancer, or you can deploy the application like to the same fleet and have a feature toggle that will let you enable a particular behavior or disable it as we go. However, in order to do that, you need to keep all your changes both backwards and forwards compatible, and you need to rerun your A/B tests periodically. So generally, this is harder to maintain, but still worth doing, because then you can avoid like long deployments going through multiple stages, and you can quickly roll things back if needed. However, they require some more, let's call it a better process, more structured process, to make sure that you do not deploy something that is not compatible. Ultimately, apart from testing the stuff, we also want to have metrics. And when it comes to metrics, you need to have dashboards. Don't create dashboards manually. Always configure dashboards again as code, so they are deployed automatically. Store your dashboards this way so you can scale out easily, and you can run things against these dashboards much easier. So you can run anomaly detection, you can configure alarms based on these dashboards, you can roll the things back when they break, you can block the deployments when alarms are red or whatever else. Generally, this is something you need to do in order to keep your application in shape, because, well, you can't find all the issues before going to production, but still you can find those issues just by examining those dashboards. And when it comes to the hygiene of those, have automated solutions for anomaly detection, and also reviews these dashboards periodically, like weekly, monthly, quarterly, just to make sure that you have similar weekly traffic patterns or whatever else, and then things do not rot over time. Couple more stuff to wrap up. Whenever you have backups in your systems, test your backups properly. This is again part of the infrastructure as code, because we want to create the new environment, but we also want to restore the environment based on the data we already have. And you should definitely know the answers for the questions like, how fast can you restore the backup? How long it's going to take? Who takes the backup? Who maintains it? Where it's stored? Can it be like extracted? Can it be stolen or whatever else? And if you can, migrate to different provider. You may be shut down from using any cloud provider any day. And in that case, you need to know how long it would take you to migrate to different cloud provider. So generally, do those things again, automatically, periodically, and avoid vendor lock-in where possible. Similarly, for rollback things, whenever things go wrong and you realize, okay, we let broken changes being deployed to production. Do you keep compatibility? Do you have audits? How can you roll things back? Can you even roll things back on the infrastructure level? Maybe there are changes that you can't roll back, right? Maybe you are changing your networking. And if you change the networking, then, well, there is no turning back. What about caches? What about transient and ephemeral things that can be broken or redeployed during the deployment? So generally, in order to do that stuff, perform like updates wherever it's possible and be able to roll things back via feature toggles, via deploying things on the site and just route the traffic to different fleet, delivering software like with both algorithms or with both code versions, old and new, so you can easily move back and forth. Those are the things that we need to be aware of, that they may be needed one day. And the worst case is we will need them 6 p.m. on Friday evening. So we had better tested them out before Friday evening comes. So this is what we should be doing. Summary. We discussed many stuff. We discussed many things today. And the very first thing we discussed was, do we need tests? Do we need tests at all? Everything is expensive. We don't implement software just for the sake of implementing the software. We implement the solutions and test them to basically solve business needs. And with that in mind, we always need to make conscious decisions, whether we test the software, how much we pay, how much time we can spend on it, and what to do if something breaks. Generally, avoid using mocks where possible, because mocks never represent the actual production piece. Sometimes it's not a problem. Sometimes we have like 5 nines compatibility with production piece. Sometimes it's only merely a piece that resembles the contract. Don't do it blindly. Always consider what you can do, how much time it would take, and whatnot. Remember about those 3 aspects of developer experience, right? You want to run things locally, otherwise you just won't run tests. And if you don't run tests, your application will be broken sooner or later. You want to have automated feature testing with all the infrastructure on the site. And finally, last but not least, everything needs to be automated. No manual steps. Everything should run smoothly, so that you just do git commit, git push, and there you go. And that's it. And being all of that said, I'd like to thank you for listening to this talk. And if you do have any questions, then feel free to ask them now. There is another question I can see. Do you have any recommendation for a small team of developers without QA? That's a very good question. Now, this is something actually pretty common, I'd say. Many companies, actually the whole DevOps culture is about putting more and more responsibilities on the developers. So they do the development and they do the deployment and observability, operation excellence, or whatever else. And especially in many companies, there are not dedicated people for doing QA because, well, it's sometimes better just to put testing on the developers, especially big corps. They often do it. So recommendations from my end would be, generally, if you do not have the separate QA team, then you don't want to spend much time on QAing, or actually more time than needed, meaning that focus on automation as much as possible. Focus on all the automation and test stuff automatically as much as possible. Avoid doing manual tests. Avoid doing tests with, let's say, Selenium, because they are broken, fragile, and slow. Generally, focus on automation of the deployment, good unit tests, and being able to verify these things with all the tools you have. Next thing is, some QA tests can be performed by the computers thanks to some dedicated tooling, as I mentioned. You can have actually like fewer improvers, you can have some chaos engineering, you can have some mutation tests, etc. That will actually look for issues in very similar way to what QA team does. So generally, I would focus initially or first on those automated solutions. But like, you probably won't avoid doing the testing on your own anyway, right? If you don't have another QA team, then, well, you need to do some QAing anyway. So automate as much as possible and limit the amount of manual work you need to do. Are there any other questions?
I just want to remind you, so if you want to talk to us, you can push raise hand button and I'll also unmute you. But if it's okay for you, you can still use chat.
Okay, seems like that's it. So let me wrap up. If you would like to learn more about the stuff I showed you today, I encourage you to take a look at stuff like C4 models as code or plant UML in general. Look for solutions that can automate generation of the diagrams, or capturing how your applications work, or logging in better way. And generally those things, they can help you, generate the trace of what happened automatically so that you can compare it easily. Think about solutions that make sure that your code works without testing it. Like 𝐀𝐝𝐚𝐦 is the language that can actually prove a lot of stuff for you. For instance, that whether your list that is a parameter to a function has exactly 2 elements, if that's what you need, right? Use TLA plus other stuff. There is a link. Read about deployments, observability, why it's important, and I also encourage you to take a look at my blog to see what I have to say about various testing principles. And now coming back to questions, there is a question from Ismail about timing in agile projects. How many points can we add to a ticket to test it? I don't want you to get me started, but generally, I'll try to keep this short. Generally, whenever let's think about why we even have points in our agile teams. Points were introduced or added to software engineering just because we as software engineers claimed that we can't estimate stuff in a longer run for months in advance because it's undoable. We can't estimate stuff in hours because we have no idea how long it's gonna take and the variance is too big. So instead, we decided to use points to mark the relative difficulty or relative scope of all the work that needs to be done in a given task. So with points, we don't say that this is going to take 5 points, which means X number of days. Instead, we are saying this is 5 points and this other task is 7 points. So this other task is bigger. This is what we want to achieve in points. Now, If you do sprint planning, which let's say takes 2 weeks, sprint is 2 weeks long, then there is absolutely no reason and no value in using points, because points are not for estimating particular sprint. In particular sprint, you should be estimating in hours. That probably should be a talk on its own, how to estimate stuff and how to run agile, but generally this is in a nutshell how it should work. So now coming back to the question, how many points can we add to a ticket to test it? We shouldn't be talking about points, we shouldn't be talking about time. Now, how much time do you need? Depends on the task. Sometimes it can be 1 hour to just, implement unit tests or even less. Sometimes we need to actually accommodate like a couple of days to test the stuff. If you map points to hours or working days, then obviously you need to act accordingly. But generally, good practice, I think it's not about having let's say a matrix, how many points you add or how much time you need, but instead having all the solutions automated. So then you don't actually need to do nothing to test the solution. You just push your feature branch and it's being tested automatically. And the only thing you need to do is you estimate the whole implementation effort as a whole. So you have tests part of your development time. And in that case, it's only what you do. TDD, or maybe test first or test after implementation, up to you. But generally, apart from writing those tests, everything else should be automated and completely external to the feature you built. Another question we have, any idea on how to implement and automate tests regarding data accuracy or the correctness of data displayed in a report dashboard? That is a very good question. So we can actually come back to this slide because it was touching upon this topic. Whenever we talk about data accuracy, the thing we can do is we can verify distribution of data. So you need to basically do some manual work and let's say take your data set, some exemplary data set, and check, okay, how many nulls I have in this data set? What is the distribution of dates? How many numbers are in this range, etc., etc. You capture some of those. I don't know whether that could be metrics, that could be some automated unit tests with hard-coded values, doesn't matter actually, but you need to have these things written down. And then you can verify your data accuracy based on analyzing data distribution over time. So you track the data distribution against your production data set. And if you notice that there is anomaly, data distribution changed significantly, maybe that's a sign that something broke, or maybe that's a sign that something changed, which is completely understandable, but still it would be worth to acknowledge that explicitly. When it comes to displaying the data, well, you can run some, let's say, UI tests, or generally you could run tests that would read the reports afterward and compare whether those, do some sanity checks, whether those values, they make sense or not. If you want to do that, the important part is that your documents that you build or dashboards that you build can be consumed by a computer, meaning that whenever you have a dashboard, always try keeping, for instance, a big JSON object representing the state of this dashboard, right? So you don't need to read metrics from like the web browser, but you just take this JSON object and compare it automatically. Whenever you generate invoices, make sure how you generate them so that you can analyze them automatically without using OCR and any like scanning that is error prone. Those are the ways you can do. Now the question is what actually you need to do and what you want to avoid. If you suspect that your report is going to show data which is like, let's say, off by 1, then it's much different case than if your report like you miss couple of million US dollars in the reports, right? Because the latter you can typically test with data distribution. The former would be probably very strict and very narrow and much harder to maintain in the longer run. So maybe we don't need that at all. And if we do, then probably we just need to hard code those values and do it like this. Do we have any other questions? I don't see anything on the chat. And it seems like we are already out of time. So being that said, I'd like to thank you for coming to this talk. If you'd like to ask more questions, drop me a line, email, Twitter. You can find me on the internet easily. Here is the QR code to slide deck. And thank you for listening. Back to you, Diana.